Evaluate the limit as x approaches 0 of cosecant 8x over cosecant 4x. Now first off, let's try plugging in x equals 0. So we know cosecant of an angle is 1 over sine of that angle. So it's 1 over sine of 8x and 1 over sine of 4x. If we plug in x equals 0, we'll have sine of 0 in both cases. And sine of 0 is 0, meaning we'll divide by 0 and we'll get undefined. So we can't just plug in 0. So what we have to do is do some algebra, some manipulation of this expression in order to get a limit. So again, I wrote it as a reciprocal and I simplified it, and you'll get sine of 4x over sine of 8x. But still, even from this, you still can't plug in 0 because you would be dividing by 0, because sine of 0 is 0. So what we have to do is use these fundamental trig limits, which are the limit as x approaches 0 of sine x over x equals 1. And also keep in mind that if we take the reciprocal of both sides and take the limit of sine of x over sine x as x approaches 0, that would be equal to 1 over 1, which is just 1. So in other words, both of these limits are equal to 1. And so we can do that to kind of create our sine x over x. Remember, x just represents any angle. As long as that angle is equal to the angle in the denominator, it will be equal to 1. So here, sine 4x, we want a sine 4x in the, not a sine 4x, just a 4x in the denominator. And so we're going to multiply by 4x over 4x. That would give us, again, our sine 4x over 4x, because that limit would be 1. And we also want a 8x in the numerator. So I'm going to, well, we already have a 4x, so I'm going to multiply it by 2. But to do that, we have to multiply by 2 over 2. And so now, if I rewrite this, I'm going to get 8x divided by sine of 8x multiplied by sine 4x over 4x. And notice we have this extra 2 here. So I'm going to bring that out in the front as 1/2. And we know that the limit of a product of two things is the same as the limit of each individual one. And this goes to 1, and this goes to 1. And so 1/2 times 1 times 1 gives us 1/2. And so that is our final answer.